We've learned that a method is a collection of code that's grouped together to perform a single task or action. Often, a method will need some information to complete that task. For example, consider this method that prints the area of a circle using the formula pi r squared. We'll approximate pi as 3.14, and the radius here is 14.5. To square that, I'll just multiply it times itself. This calculation evaluates to 660.185. Actually, because we're dealing with floating point numbers, we get a slightly imprecise result with a bunch of decimal places, but at this stage in our learning, we don't bother with rounding that off. The problem with this example is, every time we run this, we're going to get that same output because my arithmetic operations are using literal constants that won't ever change. Let's look at how we might use this method in our main method. This code uses a scanner object to get a double from the user and store it in a variable called radius. So we'll just need to use that variable in our calculation, right? As the Beatles once said,
Because I told you before, oh, you can't do that.
you can't do that. A variable only exists inside the code block in which it was declared. We call that the variable's scope. So the radius variable can only be accessed inside the main method, and if we write code in the print area method that tries to access it, our program won't compile. It's out of scope. One solution students often try is to move that declaration statement outside of main so that the variable's scope is the whole program instead of just one method. The Beatles didn't have a song called You Shouldn't Do That, but you shouldn't do that. Maybe Tom Petty can help.
Don't do it like that. Don't do it like that.
It will work, but that's what we call a global variable, and we avoid them whenever we can. For now, you should avoid it because you won't get any points on your assignment if you use global variables, and I guess if you get a job doing this, you'll just get yelled at by your boss. We want to get in the habit of keeping our data compartmentalized. If a different method needs that value, we can pass it, like a football. To do that, we define a special kind of variable in our method called a parameter. A parameter catches a value that's passed when the method is called, and we can use that parameter however we want. To create a parameter, you'll declare the variable right inside the parentheses in the method header. A few things about this identifier. First is that we can name it however we want as long as we follow Java's rules for identifiers, like not starting with a number. But since our parameter has a different scope than main, we could even use the same name and call it radius. What was that Tom Petty said?
Don't do it like that. Don't do it like that.
Again, just because you can do something doesn't mean you should. Naming it radius would be less offensive than making radius global, but using the same identifier twice just leads to unnecessary confusion. So just don't do it. The second thing about this identifier is that I seem to be violating my own rule about being descriptive. After all, didn't I say we shouldn't call them things like x? But I feel like this is a reasonable exception since the formula everyone knows is pi r squared. So naming it r probably helps with clarity, and since I've already used radius, I think this one is okay. We still have an out-of-scope reference here because our formula refers to radius, so we need to change those to r. That fixes our method so that it compiles, and the method really should work now. But fixing that error has caused an error in a completely different part of the program. Welcome to the world of coding. Defining a parameter for a method essentially establishes a rule. We're saying that if we want to use the print area method, we have to provide a value for r. The method can't execute without it. So anytime we call the method, we have to provide that value. The value goes inside the parentheses when we call the method. When we put a value there, we refer to that as an argument. That can be a little confusing. When we're calling a method, it's an argument, but the variable inside the method is called a parameter. Some people use those words interchangeably, but we'll try to be accurate and use the correct terms. As soon as I provide that value, the error goes away because now I'm following the rules of the method, as long as the argument I provide is the correct data type. It turns out that we've been using arguments all along, like when we call print or print line. The string we want to output is an argument. In our example, I've provided the numeric literal 14.5. This works and our program will execute without any problems. You can also use a variable instead of a numeric literal. Now, whatever value the user has input will be passed to the print area method and used in that calculation. When an argument is of a primitive data type, basically all the data types that start with lowercase letters like int and double, the parameter gets a copy of the value. If the code inside the method changes the value of the parameter, the argument value doesn't change. This version of the method results in the same calculation, but in the process, it squares the parameter r and saves that back to the variable r. But the radius variable isn't changed. But just so you know, this won't be the case when we learn about objects, and we'll get to that later. If a method needs more than one piece of data, we can have additional parameters. To calculate the area of an oval, we'll need two different radius numbers, the larger one and the smaller one. So this method has two parameters, small radius and big radius. So now I've basically made a rule that says in order to call the print area of oval method, I'll have to provide two numbers. So my method call has two arguments. I've just used numeric literals here, but those can also be variables just like we saw before. By using parameters, we can pass necessary data to methods, ensuring our code remains organized, reusable, and maintainable.